Here's a nice puzzle involving bases from me. Given a positive integer n, I write the base 11 representation of n, then the base 16 representation of n. The symbols I write down are 2, 3, 5, 8, another 8, and b in some order. What is n in base 10? Given these digits, let's first think about what possible digits could be in the base 11 and base 16 representations. Recall that a base 11 representation can only contain the digits 1 through 9, as well as the letter A representing 10, right? And 16 can only involve 0 through 9 and A through F, the letters A through F. Given that B is in one of these representations, it follows that B must be in the base 16 representation. So if you imagine the base 11 versus base 16, well, B is definitely in the base 16 somewhere. Also, given that there's 6 total digits, the answer is probably going to be, right, 3 digits, or the 2 representations are probably going to be 3 digits, right? Something, 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 and something, something, something. If one of them had 4 digits and the other one had 2, well, in order for them to even have a chance of them being equal, we're probably going to have the 4-digit number being base 11 and the 3-digit or 2-digit number to have base 16, right? Because otherwise the difference would be even larger if we consider, right, in base 10, if we had a base 16 4-digit number and a base 11 2-digit number, those would definitely be farther apart, right? In particular, this number is bounded between 11 cubed and 11 to the 4 minus 1, right? And this 16 is going to be bounded between 16 squared and 16 cubed minus 1. Notice that this is around, I think 16 squared is 256. Multiply that by 16, you get about 4,000. Right, so we know that this number is definitely less than 4,000. This number is 11 cubed, so that's like 1331. So we can see that, yeah, I mean, there is a possibility, but this number would have to be really big, right? So, or sorry, this would be 16 squared minus 1, so that's only 255. We can see that a 2-digit base 16 number is definitely not that big, right? Definitely not as big as this. So we know that, yeah, for sure, the base 16 number has to have 3 digits. And so it is the base 11. Okay, now that we've gotten that out of the way, we know that there's another number here, and another number here, and a number 3 numbers in the base 11 representation. We're kind of stuck now, right? We don't really have any other way to move forward except, trying everything out. But there happens to be a nice idea that we can exploit. In particular, remember divisibility rules. In base 10 decimal, we have a nice divisibility rule for 9, right? In particular, if a number is divisible by 9, then the sum of the digits is also divisible by 9. And even more generally, n is congruent to the sum of its digits mod 9, meaning they leave the same remainder. We can derive this because the base 10 representation involves, imagine writing the base 10 representation out like this. Notice that all of these powers of 10 can be rewritten as just 1 to the power of 0, 1, 2, and so on. So these are actually just all 1, and you can verify, right? 100 is just going to be 99 plus 1, and so on. So actually, this is just equivalent to the sum of the digits. In particular, any base, right? Given a base b, n is congruent to the sum of its digits in base b mod b minus 1, right? Because if you have b to the power of k, that's going to be 1 modulo b minus 1, right? It's just a bunch of 1s multiplied together. So we can use the same thing here. Notice that these 3 numbers are congruent to some number mod 10, and these 3 numbers, when we add them up, are congruent to some number mod 15. In particular, we know that, right, this same number, if we say that the n in base 10 is just n, then n is congruent to this number, the sum of these 3 digits mod 10, and the sum of these 3 digits mod 15. Notice anything special about 10 and 15? They're both multiples of 5. And notice that since n, right, is the same number in both of these, that the sum of the digits in base 11 and the sum of the digits in base 16 have to be the same mod 5, right? Because n, right, this number mod 10 is n, this number mod 15 is also n, so that means that, you know, this number is also equivalent to this mod 5, and so is this. So it follows that these two sums are also divisible, or not divisible by 5 necessarily, but they have the same remainder when divided by 5. And we can quickly add up all these numbers. You know, b is 11, right, because a is 10, b is 11, f is 15, and so on. So that this adds up to, well, 2 plus 3 plus 5 is 10, plus a is 18, then 26, and 37. That's congruent to 2 mod 5. So from that alone, we can conclude that, well, if the sum of two numbers that are the same mod 5 are 2 mod 5, then each of these adds up to 1 mod 5, right? So let's take a look. Let's first take a look at the base 16 number. Well, the sum of these 3 digits are 1 mod 5, and we already have a b, which is 11. So it follows that these two numbers must add up to a multiple of 5, because b is already 1 mod 5. If we take a look at the pairs of numbers here that are divisible by 5, when we add them up, well, mod 5, well, you have 2, you have 5, which is already a multiple of 5. 5 can't pair with anything. So we end up with 2, 3, 8, 8, and 3, 8, and 8 are all divisible, or all 3 mod 5. So we can see that we have to pair 2 with some other number, 3, 8, or 8 mod 5, right? 2 plus 3 is going to be a divisible by 5, and no other pair works. So it follows that this number is going, there's definitely a 2 somewhere there, and then the other number is going to be 3 or 8. It follows that the remaining numbers here, well, we know that 5 then has to lie here. So 2b and then either 3 or 8. So then the other number is 3. The other two numbers are 3 or 8, right? So now we have this, and we can now just sort of do some work to figure out which combination it is, right? In particular, we can quickly figure out how big or small the first digits need to be, right? So let's take a look. Well, let's start a new page first. So recall that the base 11 digits are 5, and then a 3 or an 8, and a 3 or an 8 in some order. The base 16 are going to be 2, b, and then a 3 or an 8, right? And you know that 2 of these are going to be 8s, and one of them is going to be a 3. Okay, let's take a look. Well, we know that if we should probably get rid of the extremes first. Imagine a base 16 number starting with b. Well, that's going to be at least 11 times 16 squared, which, if you calculate that, is going to be 256 times 11. That's going to be 2816, right? And notice that that's greater than 11 cubed. So that tells us that the corresponding base 11 number would definitely have more 3 digits or more, or 4 digits or more, right? Because 11 cubed would always already be a 4-digit number, model of base 11. So you know that the first number is not b. So we know that b lies in later 2 digits. Let's think about, how about 2? Well, if we had a 2 there, then that would be, we can bound that by saying it's definitely between 2 times 16 squared and 3 times 16 squared, excluding 3 times 16 squared. It's going to be 512, and that's going to be, whatever 256 times 3 is, 768. So what would that be in base 11? Well, we know that these right, are going to have some number times 121. The largest number that 121 goes into 512 is 4. And in this case, that would be 6, right? That would be 726, and this would be 484. So then we can see that in this case, it would start with 4, base 11, and the upper limit would start with 6. So you can see that the only number out of 3, 5, and 8 that are in the base 11 representation, well then 5 is the only number base 11 that works. So now we have this, and we can see that in this case, well then 2 is something, and then this starts with 5, so we already know that this is bounded by 5 times 121, which is 605, and it's at most 6 times 121, which is 726 again. And then we can sort of do the same thing, right? Now that we have a tighter bound, we can consider base 16, right? Well, first of all, right, 605 is going to be 256 times 2 plus something. We already know that it starts with 2, right? So we can subtract 512 from these to see what we can bound this number now, right? Getting rid of that first digit. The 2-digit number in base 16 then has to be between 93 and 214, right? Base 16. Well, then 93 is already something like 5, and then like B or C or something. I think it's E? No, D. Okay. It doesn't matter, right? It starts with a 5, so we know that the next number past the 2 is at least 5. I think it's at most 214 over 16 is going to be pretty close to 1, 3 point stuff, and that's going to be, I think, also D. So you can see that the number ranges from 5 to D, so it's either 8 or B. So let's try the two possibilities, right? 2, 8B. It could be also 2B and then 3 or 8. Or it's 2, yeah, so it's either 2B3, 2B8, or 2AB in the case that it starts with 2. And we can see that, okay, let's just calculate these now. 2,8B is just, right, there are a few enough cases that we can just sort of check them all. 8 times 16 is 128, B is 11. So that adds up to 640 plus 11, 651. Base 11, that's going to be 5. So 5 times 121 is 605. 651 minus that would be 46. So that would be 4 followed by 2. So that doesn't work. Check 2B3, base 16. Well, we still have 512, and then 16 times 11 is 176. So that would be 688. And then plus 3 would be 691. Base 11, that would be, let's subtract, then it would start with, so it's 11 squared times, 5, so that would be 605 again. 691 minus that is going to be equal to 86. So that's going to be 5, and then that goes into it 7 times, and then that leaves a remainder of 9, I think. Yeah. Okay. So that's not it. And then finally 2B8 would just be that plus 5, 696. Let's see. It's going to start with 5, and then subtracting out, right, that would end up with 91. So it would be 8, and then 3, 11. And you see that 583 and 2B8 do work. And by using more bounding or just trying more examples, the rest of the possibilities where the base 16 number starts with an 8, for example, I think doesn't work. And also if it starts with 3, we can verify that no such numbers exist either. So we end up with an answer of 696 in base 10 And that is our final answer.